Every single day, across the globe, billions of people turn a simple dial, and a clean, blue flame springs to life. It cooks our meals, warms our homes in the dead of winter, and powers massive industrial machines. It doesn't magically appear in that heavy steel cylinder outside your home. Its journey is a spectacular tale of geology, a journey that begins not in a factory, but hundreds of millions of years ago, buried miles beneath the Earth's surface. From the ancient, high-pressure depths of the Earth, through the blazing heat of mega-refineries, to the high-tech forging of steel cylinders, our story starts deep underground, hundreds of millions of years ago, before dinosaurs even walked the Earth. Microscopic marine plants and animals died and sank to the bottom of ancient oceans. Over millennia, they were buried under countless layers of sand, silt, and rock. Crushed by this organic matter slowly transformed. It became what we now know as crude oil and natural gas. To reach this buried treasure, massive drilling rigs pierce the Earth's crust, boring down through solid rock for miles. Once the reservoir is tapped, giant pump jacks take over, pulling this thick, black crude oil to the surface. But they also extract something else: associated gas, a chaotic, highly volatile mixture that used to just be burned away. Today, this raw gas is trapped, harnessed, and sent through thousands of miles of high-pressure steel pipelines, beginning its journey to the chemical crucible. The pipelines eventually lead here, the refinery, a sprawling, metallic labyrinth that operates. It looks like a city of steel, and it is here that the raw, chaotic crude oil and natural gas are tamed and separated. When the crude mixture arrives, it is completely useless to us in its current state. To extract the LPG, we have to use one of the most fundamental laws of physics: boiling points. The crude oil is pumped into a massive furnace and heated to a blistering 400 degrees Celsius. At this extreme temperature, the oil boils and turns into a thick vapor. This superheated vapor is then fed into the bottom of a towering structure known as a fractional distillation column. Inside this colossal tower, the temperature is carefully controlled. It is incredibly hot at the bottom and gradually cooler at the top. As the vapor rises, different chemicals hit their specific boiling points and condense back into liquids. Heavy materials drop to the bottom, while diesel settles in the middle. But the lightest, most volatile hydrocarbons never turn back into liquid inside this tower. They rise all the way to the very top as a gas. These specific hydrocarbons are propane and butane. Together, these two gases are the sole ingredients of LPG. They are extracted from the top of the tower, completely separated from the heavy crude oil. Through a complex series of pressure-controlled valves and heat exchangers, these raw gases are captured and purified. But the journey of our blue flame is far from over. It must now face the ultimate test of pressure. We now have pure propane and butane. But there is a massive logistical nightmare. Transporting gas is incredibly inefficient. In its gaseous state, it takes up far too much volume. The solution? The gas is routed into enormous industrial compressors and cryogenic cooling chambers. Subjected to immense pressure and rapid cooling, the gas collapses into a dense, clear liquid. This is the L in LPG. As a liquid, LPG takes up 250 times less space. But pure LPG is completely odorless, To make it safe, scientists inject a chemical called ethyl mercaptan, giving the gas its distinct, engineered warning smell.
Now fully processed and odorized, this highly concentrated liquid energy needs to be stored safely.
It is pumped into gigantic, heavily pressurized white spherical tanks known as Horton spheres. Their perfectly round shape distributes the massive internal pressure equally across the steel, making them the safest way to store millions of gallons. While the liquid gas waits securely, a completely different industrial ballet is taking place miles away. The creation of the vessel that will carry this pressurized liquid into your home. The LPG cylinder. These aren't just simple metal bottles. They are highly engineered pressure vessels. With hundreds of tons of force, the press punches out flat circular discs and instantly crushes them into perfect, deep-drawn domes.
2 of these domes are brought together. Automated robotic arms, moving with surgical precision.
Weld the 2 halves together using submerged arc welding. This creates a seam that is actually stronger than the steel itself.
But the heat from the welding process leaves microscopic stress fractures in the metal. To fix this, the cylinders are sent through an annealing furnace, a literal tunnel of fire heated to 900 degrees Celsius.
This extreme heat relaxes the steel's molecular structure, making the cylinder incredibly tough and shatterproof.
The cylinders are now locked, loaded, and ready to move.
They are grouped together, building a massive arsenal of portable energy. A staging ground for millions of units, awaiting their final deployment across the nation.
These trucks become the arteries of the nation, traveling across major highways and navigating treacherous mountain passes.
They are delivered to local distribution hubs and eventually right into your neighborhood. These trucks become the arteries of the nation, traveling across major highways and navigating treacherous mountain passes. From the crushed remains of prehistoric life, buried miles beneath the desert sand,